Hello everyone. So welcome back again. And the topic for the day is the VPN. Okay. In VPN, we are going to discuss about the IPsec over GRE tunnel. Well, we already have uploaded a video in which we have explained the GRE tunnel. You can also watch that before this video. Okay. We have properly explained about the GRE configuration and what is GRE tunnel. Okay. Now, why do we need the IPsec over GRE? Well, we already have other VPN like DM VPN. Okay. We are generally using the DM VPN. Okay. But this is also important. Like if we have 2 to 3 site, we can initiate the GRE with the help of IPsec encryption. Okay. So why don't we do configuration of GRE tunnel alone? Because it support routing protocol but no encryption. Because encryption is not available in plain GRE. Okay. What is the benefit of IPsec? IPsec provide the encryption, but it doesn't support the multicast or dynamic routing. So if we do the configuration of both IPsec and GRE, then it will support both encrypted tunnel as well as multicast and the routing protocols including the IP version 6. Okay. Well, how IPsec over GRE works? A GRE tunnel, we already know that it is configured between the source and destination with a proper private network. Okay. It supports the dynamic protocol run over the tunnel in GRE. Okay. The traffic GRE is then encrypted by IPsec. It means first we do the configuration of GRE, then we will do the encryption on that with the help of IPsec. Okay. So this is our topology on which we are going to do the configuration of IPsec over GRE. So for that, in first step, we are going to do the configuration of GRE tunnel. Then we will apply the IPsec configuration over the GRE tunnel to create a secure encrypted tunnel in between the source R1 and the destination R4. The tunnel will having the interfaces 172.16.0.1 and 172.16.0.2. Also, we will do the configuration of EIGRP in between them. Well, we can do the configuration of other protocol also. We can use the protocol like OSPF in between them. So it's not necessary that EIGRP must be there. Well, this is just an example, so we can take any of these. Even our routing information protocol can also be configured. Static routing is also available. So don't be worried about that, okay? Well, I already have discussed that multicasting is used. That is why I'm doing all that. Okay. Now, as we can see, there are four routers R1, R2, R3, and R4. So, first of all, we will do the configuration of EIGRP to reach R1 to R4. Then we will create a tunnel in between them. Then we will do the configuration of IPsec over there. Okay, so let's go to our GNS3 on which I already have prepared the topology. Okay, here we have R1, R2, R3, R4 and R5. I already have configured the basic EIGRP on this network. Okay, so let me show you in the routing table of R1 that I already have configured the EIGRP over here. How? Do show IP route. So in routing table you can see that all the networks are available in the table. Okay, and also uh, they can able to ping R1 can able to ping R4 because the network is reachable also in the table. Let me show you do ping 192.168.12.2. So you can see it is pinging perfectly. Okay. Now, what is our next task? Our next task is to perform the GRE configure, or let's create a GRE tunnel in between R1 and R4. That is already done in our previous video also. If you want to take the reference, you can go through that video. Okay. So let's create a tunnel in between R1 and R4. How we can do that? Go to R1, put a command which interface tunnel 0. Okay. Then you have to provide a private IP address to this tunnel. Okay. So tunnel is up now. Well, but it is showing down because on other side it is still in down state. So let me provide this IP address to the tunnel interface, and it will become our source IP of the tunnel also. Okay. So IP address of the tunnel will be 172.16.0.1 and with subnet mask 255.255.255.252. Okay, that's it. Now 192.168 will work as a tunnel source. So let me provide that also. Okay, so tunnel source is 192.168.10.1. Okay, and the tunnel destination will be 192.168.12.2. Here it is the tunnel destination that belong to F0/0 physical interface. Source belong to F0/0 physical interface of R1. Okay, so when I will provide the destination, almost my configuration is done to initiate the tunnel. Okay, let's put exit. So I have initiated the GRE tunnel in between R1 and R4. Let me also do the configuration on R4. Okay, so let me go to R4 and do the configuration of tunnel. Okay, how we can do that? Interface tunnel 0 in the same way. IP address is 172.16.0.2. Okay, and also let's provide the subnet mask 255.255.255.252. So we have provided the IP address to the destination also. In the same way, let's mention the source and destination of the tunnel. So tunnel source according to the R4 is 192.168.12.2. The physical interface IP will work as the tunnel source. Okay, because all the data should be forwarded through this, but with a private network. That is why we have to mention the source and destination. Okay, tunnel destination will be 192.168.10.1. Now all the configuration is done now, and we can see that the tunnel is up. Okay, now what is our next task? Our next task is to do the configuration of EIGRP in between these tunnel interfaces, and we know that the network between them is what? 172.16.0.0. Let me mention that the network in between them will become 172.16.0.0 with a subnet mask wildcard mask 0.0.0.3. Okay, so let me do the configuration of this also in between R1 and R4. Okay, let's go to R1 and do the configuration of EIGRP over here. Okay, router EIGRP 100 and network is 172. Well, we also put a command no auto summary. Okay, then network, this is 172.16.0.0 and 0.0.0.255. Okay, 0.0.0.3. This will be the wildcard mask for the 255.255.255.252. Okay, so we have advertised the network over here. In the same way, let's advertise the other network 192.168.10.0. Well, we already have provided that in our previous configuration and put exit over here. In the same way, put the same configuration on R4, then GRE configuration will be done. Okay, so router EIGRP 100 network 172.16.0.0 and 0.0.0.3. Okay, other network, this is 192.168.12.0. That's it. Okay, put exit over here. So here we can see that we have do the configuration of both configuration of network in source and destination. Okay, so let me go to source again. Here we have provided the network configuration in between the tunnel. Okay, and I think we have forgot the command no auto, oh sorry, auto summary. Okay, now all the configuration is done perfectly. Okay, now let me go to the table of R1. Do show IP route. So here we can see in routing table we have networks available and tunnel is also connected with that. Okay, if I will go to the tunnel interface, show interfaces, show, oh sorry, do show interface tunnel. Okay, tunnel 0. Here we can see that tunnel is up. Okay, and this is my IP address, source IP, and so on. So everything is working perfectly. Okay, now it's time to do the configuration of what. Well, in tunnel 0 on R4 we have provided the wrong IP address here. Okay, let's correct this IP. Okay, how we can do that? Go to the tunnel interface again, tunnel interface 0, tunnel interface tunnel 0. Actually we have provided the wrong IP address. The IP address is 172.16.0.2 and 255.255.255.252. So this is the correct configuration, and you can see that after providing the correct IP address, the EIGRP in between R1 and R4 will be initiated. Okay, let me check the routing table now. Do show IP route. So you can see that the route will be available in the table now. Okay, with the two subnet and two subnet mask over here. Okay, let me check the tunnel. Okay, so how we can do that? Show interface do show interface tunnel 0. Do show interface tunnel 0. Here we can see that now everything is available in the table, and we can easily able to reach in between R1 to R4 with the help of GRE. Okay, But the problem is that this tunnel is insecure. Why? Because we didn't have configured the IPSec over here. So let's do the configuration of IPSec. Okay, initiated from R1. How we can do that? First of all, we will create the ISAKMP policy on R1 with a pre-shared key. Okay, how we can do that? Crypto is ISAKMP policy 10. So let's create the policy over here. Now it will ask that which type of encryption you want to do. So I want to do the encryption of AES. Okay. The hash generator will be SHA. Okay. And authentication should be pre-shared. Okay. The group will be 2 and the lifetime of packet will be 86400. Okay, let's put exit. So we have created the policy for the crypto IPsec on R1. Now let's provide the pre-shared key as we have mentioned. Okay, so crypto ISAKMP key, that is Cisco. Let me put the key Cisco with an address of destination, that is 192.168.12.2. So that is mean this IP address should accept this key. Okay. Now in the next we have to create the transform set and access control list. Okay, so that others cannot able to access it. How we can do that? Crypto IPsec, okay, transform set, GRE set, okay, ESP hyphen AES encryption, okay, ESP hyphen SHA encryption with H MAC, okay. The mode should be transport, okay, and you can put exit over here. In the same way, apply this crypto map over the interface of R1. Okay, how we can do that? Crypto map, the name will be VPN hyphen map. Dear, please do remember that the name should be exact on source and destination. Okay, map 10 IP sec ISA KMP. Okay, now set, we have to set the peer. It is showing that this crypto will remain disabled until a peer and a valid access list have been configured. Okay, so we have to set the peer also. Set peer 192.168.12.2. Okay, set transform set should be GRE hyphen SET. The name we already have taken above. Okay, match the address 101. Okay, put exit over here. In last we will apply this configuration over f0/0 interface. So interface f0/0, okay, crypto map, which one? VPN hyphen MAP, the name we have taken, and put exit over here. Okay, so we can see that ISAKMP is on interface. So in the same way, we will do all configuration on R4 step by step. Let's go to R4. Okay, first of all, we will create a crypto policy, ISAKMP policy. Okay, crypto ISAKMP policy 10, like we did in on R1. Encryption should be AES, AES, okay. Hash generator is SHA. Okay, authentication is also pre-shared. Here we have to mirror all the configuration on R4. Group should be 2 as we taken on previous one. Lifetime of packet should be 86400 as we have taken in previous one. Exit. Now we have to provide a pre-shared key. Okay, the pre-shared key should be same as the previous one. Okay, that was capital Cisco. So crypto ISAKMP key is Cisco. Cisco address is 192.168.10.1. So we have to provide the source address of interface R1. Okay. Now everything is done. Now let's provide the transform set. Okay. So transform set, how we can provide that? Crypto IPSec transform set. We should give the same name GRE hyphen set. Okay. ESP is AES encryption and ESP this is SHA hyphen HMAC. Okay, like we did provided in previous one. Okay, now let's provide the mode, that is transport, and let's put exit. Now let's create an access list which permit GRE host. Okay, so access list 101 permit GRE host, that is 192.168.12.2, and host this is 192.168.10.1. Okay, so we have provided host on both the side. Let me also check on R1, do we have provided the host or not? No, we didn't have provided the host on R1. Okay, in access list, so we have to provide that also. Okay, so access list 101. Okay, permit GRE host this is 192.168.10.1 and host 192.168.12.2. Dear, this command should be provided during the initiation, okay, of transform set. That will be better. Okay, now we have created the transform set and we can see that dual neighborship is up now. Okay, but holding time is expired. Now what we have to do, let's map the crypto over here. So crypto, why it is showing this kind of message? Because we have done the encryption on one side and other side it is not accepted because of IPsec. So that is why my EIGRP neighborship is down now. Okay, crypto map VPN hyphen map 10 IPsec hyphen ISAKMP. Okay, let's map crypto on this one. So it is showing that new crypto will remain disabled until a peer and a valid access list is configured. Okay, well we have configured everything, but we didn't have set the peer. Okay, set peer. This is 192.168.10.1. Okay, set transform set GRE hyphen SET. Take the same name as the previous one. Match address 101. Okay, put exit. Now let's apply all the configuration on interface G0/0. Interface G0/0. Sorry, interface. This is F0/0. Sorry, F0/0. Crypto map VPN hyphen MAP. Same name as we have taken in the policy. Okay. Now all the configuration is done. and you can see that ISAKMP is on, and the new adjacency will be is already created with the help of IPSec. Now all the data will be forwarded in the encrypted mode. Let me check the interface. Okay, do show IP interface brief. Okay, so IP address is provided properly with the tunnel 0. We can see it is up now. Okay, now let me check the routing table. Do show IP route. So in routing table we have the network connected properly with the tunnel. Okay, and it is also working. Okay, now let me check the neighbor. This is most important command to check the neighborship. Show do show IP EIGRP neighbor. So here we can see that neighbor is available with the help of tunnel. Okay, on R4. If the neighbor is available in the table, that is means configuration is done properly. Okay. Now let me check the crypto ISAKMP. Okay. Show crypto. Sorry. Do show crypto ISAKMP, the policy. Okay, assay. Okay, so it is showing that the policy is active over here. Destination source and source is also mentioned. Okay, now let me check do IPsec. Now do show crypto IPsec assay. Okay, so it will show you that IPsec is working perfectly. The status is active. Okay, so these are the IP address available. Okay, on the tunnel. The peering is 192.168.10.1 with port number 500. Okay, so these are the local crypto and point 192.168.12.2, and a remote is 192.168.10.1. Okay, so dear, as we can see that our configuration is successful and our tunnel with IPsec is working properly. Now let me capture the packet on this uh, in between the tunnel. Okay, so let me try to ping them and we'll see the observation in the table. Let me ping from R1 to R4. Okay, so do ping which one 172.16.0.2. So it is pinging perfectly. Let me see what will be the change. Okay, here we got some messages in between the source and destination. Okay, 192.168.10.1 to the 192.168.12.2, but these messages are encrypted. Okay, let me open this. Okay, so here we can see that encapsulation security payload. Can we able to decrypt that? No, we cannot able to watch that. Okay, the data is totally encrypted, encapsulated. Okay, with the security rules, so we cannot able to capture that data forwarded in between source and destination. Okay, that is all for today. Have a nice day, everyone.